Once we give students these problems that require more than just having something memorized, they need tools. Often with students, I use a list written by a great educator named Marilyn Burns. So the problem-solving strategies on that to give you a sense: drawing a picture, making a chart or a table, making an organized list, looking for a pattern. They need to learn to persevere. You try something and it's hard and you struggle through it. One way that we can keep that struggle productive is to help students build a toolbox of problem-solving strategies.
Today in the morning session, we're going to do a problem that fits that, but again, we're going to be focusing on the problem-solving and how to create a problem-solving atmosphere in your classroom.
So there's a problem called the bicycle shop. The bicycle shop problem is essentially someone has a bicycle shop. They have bicycles and tricycles there. You're told the total number of vehicles that they have, of cycles, and the total number of wheels. And what you have to figure out is, based on those two conditions, how many of them are bicycles and how many of them are tricycles. And before they do any work, I ask them to read the problem and then look over the list and then write down any strategies they think might help.
For the problem-solving strategies, which ones stood out to you? Maybe that might be a way I could approach this problem. Just call them out, and I just want to kind of make a notation of it. Guess and check, okay? Picture. Object.
And the reason why I do that is because we need to help them develop an awareness, be conscious of when does it help to, when I'm drawing a picture, when does making a chart help, which of those strategies helps me when I get stuck.
So now share your tables. You can work in pairs or in your whole table, but now implement those, try them out, see which ones work, see which ones don't work.
So then I let them work and I let them struggle. I don't tell them how to solve that problem. I give them that problem and give them the strategies, and then they're messing around with it. And so as I'm walking around, there are a couple of different things that I'm doing. One, I'm trying to help people who are stuck. But the other thing that I'm walking around doing is, what are the problem-solving strategies that I want to highlight? For the bicycle shop problem, the 3 problem-solving strategies are drawing a picture, guess and check, and making an organized list or chart. So as students are working, what I'm doing is I'm walking around the classroom and I'm looking for someone who's got a picture, I'm looking for someone who's using guess and check, and I'm looking for someone who's making a chart.
Oh, I'm sorry, you didn't, right, you did, because it's guess and check, but you did guess and check in an organized way using a table.
Yeah, I was wondering that because that was really kind of tricky. Yeah.
And if I don't see any of those strategies, I'm going to be looking for stuck students, and I'm going to be saying, can you draw a picture of the situation or a visual representation of the situation, just so that we can kind of make sense of it? And if I'm looking for guess and check, the question I'll ask them, well, what could it be? Can there be 100 bicycles? And they'll say no, and oh, well, why not? Making a guess, but then how do you check it? And then for making an organized list or a more organized chart, I'll often ask students who have done guess and check, is there a way to organize your thinking a little bit?
And I need to be a little bit more organized on my paper here. So
yeah, and then this has been put as a table.
This is not one of those situations that I'm describing right now where I'm just going to say who wants to come up and share their answer, because I have specific things that I want to show.
So what we're going to do is we're going to look at a couple of different strategies that people have used to solve this problem, okay? And we're just going to talk about it.
And not only do I have specific things, but I have a specific order in which I want them to go up. I'm always going to have the visual one, the picture, go up first. That's the one that everybody can see.
So 980. So these guys are my trikes, and these guys are my bikes.
Pictures can be very elegant. When the picture goes up, there's almost always this that is really cool and interesting, and I didn't even think about it that way. And that happens both when teachers are doing this problem and when students are doing the problem.
Real simple. I missed the beginning when you decided how many bicycles you were going to start with.
Well, because the problem said that there were 36 bikes and trikes together, and we had 80 wheels. So I knew I need 36. Everything's going to get 1 wheel, and then there's no unicycle, so everything's going to get 2 wheels. And then I got to keep adding wheels to the extras until I run out of wheels.
Gotcha.
As Orlea said, so visual and also so easy. It makes sense.
Guess and check. A lot of things happen with guess and check. I want students to understand that it's actually a strategy. There's a lot to learn about how to do it. They're using the guesses that don't work to make their next guess.
48 plus 36, 84. So we're definitely going in the right direction. Now I got overconfident. So I went right to 30.
That's a really important process that takes practice. Students have to see it, but then they also have to start actually practicing how to do that, how to use the guesses and checks that don't work.
I settled on 28 and 8 was 54, 56 plus 24 equaling bullseye 80.
Your way allows you to see the pattern of what's happening in a way that the drawing one didn't quite.
Yeah, I was really
Make it as a parent.
Two things kind of happen when students look at the organized chart. One, they start seeing that you can be more thoughtful in the way you're guessing and checking. But the other thing that often comes out in conversations is that, because you can say, oh, every time I remove a bicycle, this happens to the wheels. When you have all of the numbers there, you can see patterns.
So I got to go down again. So I got to 8, and I did 24 wheels. Like, I have a good feeling about this. Drum roll, you know, and then I was like, okay, good, it's gonna work. This is 56 wheels, and that's 24, and that's 80 wheels. So there are 8 of those, and there are 28 of these.
I just like the organization of it, that you broke down into a chart. Bicycles one side, tricycles the other side.
Those 3 students are sharing their strategies not only to celebrate their own work, but because they allow us all to have to kind of think about those strategies that are going up. So then the final thing, I have students again kind of reflect on, so pick a problem-solving strategy and what have you learned about that particular problem-solving strategy. Their big takeaway is, wow, that's just crazy. Those look very different. It kind of is breaking them of the mindset of there's only one way to solve it.
I think it was very helpful. I really love having the list up. You know, I've done this with my class and I've done a table type of a situation, but I kind of just went straight into a table and as a strategy. But I like that this is actually having them kind of develop a possible list of avenues to attack something before they get to it, which I haven't really done before. So I love just like listing all the strategies first is a good starting point.
That's huge. That's a really important thing to do in the beginning of the semester, but then continually throughout. To kind of make them stretch and say, I'm learning a general problem-solving skill. I didn't just learn how to solve this one problem. And that's kind of the goal that we have with our students.